Hello. The next series of videos you will watch, I will be posting on Thursdays. I'm going to be calling it Throwback Thursday. And these are videos that I had originally posted for instructional purposes on my old YouTube channel. They did decently well, especially for somebody who wasn't maintaining a YouTube channel at the time. I hope you enjoy. Calculate residuals. Now, again, you're going to want your spreadsheet pulled up from the last 2 units. If you do not have that and you have not learned your lesson, then go ahead and pause the video right now and go ahead and prepare your spreadsheet. Okay, so directions, another mouthful. On Google Sheets, we're going to create a sheet for each problem. Enter the data, check. Create a scatter plot, check. Calculate the correlation coefficient, check. Line of regression, check. Use the line of regression to predict the y values for the corresponding x values, check. So that's all done. Finally, calculate the residuals and create a residual plot. So, residual, again, a residual is a difference between the actual data point and the line of regression. So we have our actuals in this column right here, and we have our predicted right here. So I'm going to start a fourth column right here, residuals. And we can, again, do this with a formula. We set equal, and we take this cell minus this cell, and we don't need to affix any of our values with dollar signs because we want both these to change all the way down. We want to do then B3 minus C3, B4 minus C4, and so forth. So we get our residual. So there's a difference of about 0.6, or I should say 600,000 people. Okay. And we'll go ahead and copy this all the way down. And we get all our residuals. And it's okay to have negative residuals, of course, because negative residuals would be an indicator that the actual value was less than the predicted value. That would mean that on the graph, the dot would be below the line of regression. Positive residuals would mean the line is above, or the point is below. Blah, blah. The point is above the line of regression. Okay. And what a residual plot is, kind of like a scatter plot. Okay. So what we can do is insert and create a new scatter plot. And I'm just honestly going to overlay this on top of the scatter plot. And I've actually got some editing to do. First of all, I don't need a line chart. I need a scatter chart. And there's the scatter plot. I've got my residuals here, which I want, but I need my years to be my x values. Okay. And I'm going to quickly change this to D1 so I've got the title in there. And I'm going to go ahead and quickly customize my title so I know what I'm looking at. Horizontal axis. Ugh. What are you doing to me? Here we go. Years. All right. And so there's our residual plot. And we can kind of overlay these and see if we can click on the one we need when we need it. So that's okay. Now, how do we interpret this? So we've created a residual plot. That was pretty short, but we want to interpret the results of our residual plot. Well, the residual plot is basically going to give us an indicator of, did our assumption that this is a linear data set work for us? Is linear correlation the best fit for this data? And we have to judge that based on a simple idea that the residual plot will be scattered around the x-axis if it is linear. Think about it this way. The x-axis in the residual plot represents the line of regression, as that represents all points that are 0 away from the line of regression. So if it's scattered around that evenly, that means that the points fell pretty scattered on either side. Well, when we look at this, we can clearly see somewhat of a curve to the data sets. And that would mean that a linear regression is not the best fit for this data, a nonlinear data set, or some kind of nonlinear data set. We don't know which one is best. We would have to do a little bit more investigation. So the answer to this question simply is that a nonlinear linear regression is best for this data because the residual plot is curved around the data, or around the x-axis. Sorry. So remember that. If linear was best, the residual plot would be scattered, but we can clearly see a curve. And we could even see that a little bit on our scatter plot. We can see it kind of curves a little bit around. Now, what is best? We looked at logarithmic, we looked at exponential, we looked at quadratic, we've looked at so many different kinds, just even in passing. We don't know which one is best for this data set yet. We would have to do more investigating. Now, that actually is kind of interesting because while the residual plot tells us one thing, the correlation coefficient says, wait a minute, this was a very strong linear relationship. And that's true. But the correlation coefficient is a formula, and it is only going to give you what the numbers tell you. It can be biased based on how closely they are grouped around the line of regression. It doesn't mean we can't use a linear relationship. It just means that linear relationship is not best. Something else out there is going to be a better fit for this data set. So go ahead and do the same thing for numbers 2 through 7.